probably heard the term SQL thrown around, right? It's one of those tech buzzwords. But what is it really? Well, it turns out it's the powerful, kind of hidden language that organizes our entire digital world, from your social media feed to your bank account. So, how does it all actually work? Let's break it down. I mean, think about it for a second. You go to search for a friend or a photo from last year or a product online, and bam, it's just there, instantly. How in the world does that happen? Well, that incredible speed, that accuracy, it's all about how data is stored and maybe more importantly, how we ask questions of it. And that gets us right to the core problem SQL was created to solve. All right, so here's our game plan. We're going to start with the data chaos of the past, then look at the brilliant idea that brought order to it all. We'll define what SQL is, see how it actually works with a simple example, and then we'll wrap up by weighing its incredible power against its limits. So let's rewind. Before the 1970s, digital data was, well, a bit of a mess. It was usually stored in these things called hierarchical systems. Just imagine a giant, super rigid family tree. If you wanted to find one piece of information, you had to navigate this incredibly complex maze of branches. It was clunky, it was inflexible, it was just not easy to work with at all. And then, in 1970, everything changed. A researcher over at IBM, Dr. E.F. Codd, published this one groundbreaking paper. He came up with a new and, radically simple way of looking at data. And this idea would completely change the game, setting the stage for the next 50-plus years of technology. So what was this huge idea? Honestly, it was beautiful in its simplicity. Codd basically said, hey, what if all data could just be put into simple tables? Just like a spreadsheet. Nice, clean rows and columns, and instead of all those complicated pointers, you could link the tables together using pieces of information they have in common. And just like that, the relational database was born. Okay, so let's see this in action. Here we have two separate tables, one for customers, one for accounts. See that cust ID in the customer table? That's the primary key. Think of it like a unique ID badge for every single person. Then you look over at the account table, and you see that same cust ID column. That's a foreign key. It's just a simple note that points back, creating this incredibly powerful yet simple link. We know exactly which account belongs to George. No confusing diagrams needed. Right, so we have this fantastic new way to organize data into neat little tables. Awesome. But now what? How do we actually talk to these databases? How do we ask them for stuff? Well, that's exactly where SQL comes into the picture. It was created to be the universal language for talking to these new relational databases. So here's the bottom line. SQL, which stands for Structured Query Language, is how we tell the database what to do. You want to pull up some info? You write a SQL statement or query. Want to add new data or update something? You write a query. It's the essential bridge between us and all that information. And hey, here's a little piece of tech trivia for you. People love to argue about how to say it. Is it SQL or is it SQL? Well, it turns out its name actually came from some earlier IBM projects called Square and then SQL. So yeah, whether you spell it out or say SQL, you're pretty much in the clear. So let's get into the nitty-gritty. How do you actually build one of these queries? How do you ask the database for something? The beauty of SQL is that it's just logical. It's structured almost exactly like how you'd form the question in your own head. It really just boils down to telling the database three key things. First, you say from to tell it which table to look inside. Where do I look? Then you use where to filter it down to the specific records you want. What specific things do I want? And finally, you use select to pick the columns of information you actually want it to show you. What information should I see? From, where, select. Simple as that. And here's a perfect example of a real query. We're telling the database select the first name and last name columns. Do it from the customer table, but only give me the records where the last name is Smith. The database zips off, finds Mary Smith, and gives us back just the info we asked for. This little temporary table it creates is called a result set. Now here's where the real magic happens behind the scenes. Your query gets handed off to something called a query optimizer. You can think of this as the database's brain. It analyzes your request and figures out the absolute fastest, most efficient way to get you your data. It's the secret sauce that makes all those searches on your phone feel instantaneous. So there's no doubt SQL is powerful, and it's been around for half a century. But how does it really hold up today? I mean, like any technology, it's got some massive strengths, but also some real limitations, especially now in our world of huge, massive data sets. So the advantages are huge. SQL is standardized, which means if you learn it once, you can use that skill on tons of major systems like Oracle or MySQL. It's also declarative, which is just a fancy way of saying you tell it what you want and you let the smarty pants optimizer figure out how to get it. But on the flip side, it's not a complete programming language by itself. And when you start talking about modern big data volumes, things can start to get pretty challenging. But here's the thing, you should not count SQL out. This is why this all matters so much. The language has actually evolved. There are new tools out there that let you use the same SQL commands you know and love to ask questions of all kinds of modern data sources. We're talking everything from documents to massive data lakes. SQL is adapting, and that proves just how valuable it still is. And that leaves us with a pretty fascinating question, doesn't it? A language that was invented back in the 1970s is still the backbone of our data-driven world. So, as data keeps getting bigger, faster, and just weirder, how is SQL going to keep evolving? What will its next 50 years even look like? That's a story that's still being written. Thanks for watching.